The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville.
Chapter 2, Elementary Hyperbolic Geometry. Section 41, Relation between the units of length and area of a sector and a triangle by integration. In Euclidean geometry, the units of length and area are immediately connected by taking the unit of area, the area of a square whose side is the unit length. In fact, the relationship is so obvious that there is constant confusion, though we are not always aware of it, between the area of a rectangle and the product of two numbers. Thus, modern treatment has tended to confuse the theorems of the second book of Euclid, which are purely geometrical theorems relating to areas of squares and rectangles, with algebraic theorems relating to squares and products of numbers. The expression, the product of two lines, has no meaning until we frame a suitable definition consistent with the rest of the subject matter. The area of a rectangle is not equal to the product of its sides, but the number of units of area in the area of a rectangle is equal to the product of the numbers of units of length in its sides. It would take us too far out of our way to examine completely the notion of area. We shall simply take advantage of the fact that when we are dealing with a very small region of the plane, we can apply Euclidean geometry. Thus, while there exists no such thing as a Euclidean square in non-Euclidean geometry, if we take a regular quadrilateral with all of its sides very small, we may take as its area the square of the number of units of length in its sides. Or, more accurately, the units of length and area are so adjusted that the ratio of the area of a regular quadrilateral to the square of the number of units of length in its side tends to the limit unity as the sides are indefinitely diminished. Let us apply this to find the area of a sector of a circle POQ. The angle POQ equal to theta being very small. Produce OP, OQ to P prime and Q prime. Let OP equal to OQ equal to R. PP prime equal to QQ prime equal to DR. Then the area of PQ prime P prime is equal to DR times PQ equal to K theta dr, the hyperbolic sine of R divided by K. Hence the area of the sector is equal to K squared times theta times the quantity, the hyperbolic cosine of R divided by K minus 1, is equal to 2K squared theta times the hyperbolic sine squared of R divided by 2K. And the area of the whole circle is 4 pi K squared times the hyperbolic sine squared of R divided by 2K. We can apply this now to find the area of a triangle by another method. It is sufficient to take a triangle ABC with a right angle at C, divide it into small sectors by lines drawn through A. Thus, the area is given by the integral from 0 to A of K squared dA times the quantity, the hyperbolic cosine of C divided by K minus 1. Express C in terms of A and the constant B. Write the hyperbolic tangent of B divided by K is equal to T, and put the cosine squared of A equal to Y. And we get, after some reductions, the hyperbolic cosine of C divided by K times dA is equal to minus dy divided by the quantity 2 times the square root of 1 minus y times the square root of y minus t squared is equal to minus dy divided by the quantity 2 times the square root of 1/4 times the quantity 1 minus t squared squared minus the quantity y minus 1/2 1 plus t squared squared. The integral of this term from y equal 1 to y equal the cosine squared of A is 1/2 the arc cosine of the quantity 2y minus the quantity 1 plus t squared, all divided by the quantity 1 minus t squared, equal to 1/2 times the arc cosine of the quantity 1 minus 2 times the hyperbolic cosine squared of b divided by k times the sine squared of a is equal to 1/2 the arc cosine of the quantity 1 minus 2 times cosine squared of b equal to 1/2 times the quantity pi minus 2b. Hence, the area of the triangle is equal to k squared times the quantity pi divided by 2 minus b minus a equal to k squared times the quantity pi minus pi over 2 minus a minus b.
The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons, Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.